Hey everyone, welcome back to the Whiteboard app series. In today's video, we are taking things to the next level by adding a local database using Room. And remember, if this video hits 50 likes or 50 comments, I will drop the next part of this series. So let's dive in. Let's start by adding necessary dependencies for Room and Coin. And for this, let's go to our version catalog file. And after this I will paste few more versions, and you can also get these from the GitHub repository. Here this version we will use for the Room library, and this version for the KSP, and for SQLite this version, and for Coin this version. So let's scroll down, and in the last let's add few more libraries. These two will be for Room, and with the Room we also need the SQLite library, and all these for the Coin. And scroll down, here I will paste two more plugin IDs for this KSP and this Room. And for this Room library we also have this alpha 8 version, but this alpha 8 version was giving the errors, so for now we are going to use alpha 07. And for the Coin we have specified the bills of material library, so we don't need to specify the version individually to these libraries. Next thing, let's go to our project level Gradle file, and here add those two plugins. And same plugin let's also copy in our module level Gradle build, and apply false we can remove. And in our Android main block, we can specify the libraries which are specific for this Android. And here let's copy the common dependencies. And one more thing we need to add with the Room library here in the last. This is the documentation of this Room library. So here it is saying that first we need to add these two dependencies, and we already have. And next we need to add this plugin, this we already have added. And in the last we can see here we also need to specify this Room block where we need to specify the schema directory. Let's copy this and use it here. And now let's sync our Gradle. And we got the Gradle issue, so this is saying that it is not recognizing this KSP. So here what's the solution? We can just move out this KSP dependency from here, and in the last we can specify one more block with the name dependency, and here let's use our KSP and again sync our project. So here our Gradle has been synced, and here we can see this now has recognized both these things. And let's do one more thing. Here go to our version catalog file and scroll up. Here for now we are using this Android Gradle plugin version 8.3, but we can also use the latest one. The latest one right now is 8.6.1. And the Gradle version I have, we can check from this file project structure, this 8.7, because I am using the latest Android Studio. And now sync our Gradle again. So our Gradle has been synced. Now let's rebuild our project so we can make sure that everything is working fine. And our Gradle has been successfully built. So let's close all these files. You might be wondering, why do we even need a database in our app? Well, think about it. It's crucial to save and retrieve whiteboards and their drawn paths so users don't lose their work after closing the app. Right now we are simply storing the drawn paths in the view model. But here is the catch. View model only keeps this data in memory while the app is running. The moment you close or restart the app, all your work is lost. Not ideal, right? This is where a database comes in. A database allows us to save, retrieve, and manage data efficiently over time, ensuring that the whiteboards and paths remain intact even when the app is closed. Now, what are the options available for database in Android apps? We have preference data store, a simple key value storage mechanism used for small primitive data like user preferences. However, it's not suitable for complex data like drawing paths or whiteboards. But we will use this to store the app's color scheme in upcoming videos. File storage. Great for saving files like images and audio, but not as efficient for managing structured data like rows and columns. SQLite, the default database engine on Android. It supports storing structured data in tables and lets you query this data using SQL. Room, a high level abstraction over SQLite that makes database access much simpler while still giving us all the power of SQLite. So what's SQLite? SQLite stands for Structured Query Language and it's a language used to manage relational databases. In an SQL based database like SQLite, data is organized in tables, think rows and columns, and you use SQL queries to retrieve or modify the data. But handling SQLite directly can be tricky because you will end up writing a lot of boilerplate code. And that's where Room comes in. Room is part of Android Jetpack libraries and it abstracts away a lot of complexity of working with SQLite. Here is why Room is a great choice for our app. Ease of use. Room simplifies database setup and removes a lot of repetitive code. We define our database schema using Kotlin classes and annotations, making it clean and maintainable. Compile time verification. Room checks your SQL queries at compile time. So if there is an issue, you will catch it early during development, not when the app is running. Flow integration. Room works seamlessly with Kotlin flows, making it easier to observe database changes and automatically update the UI. Room ensures that all database operations happen safely in the background without blocking the main UI thread. So let's dive in and set up Room in our whiteboard app. And that's enough talking. Now let's write the code. And here in our Compose app in the common main package, first thing, here let's create one more package with the name data. And in this package, one more package with the name local. And to implement the Room database in this Kotlin multi-platform project, we will take help from the documentation. So here is the documentation. You can also search on the Google with this name. You can find this documentation. So here let's scroll down and it is saying first we need to add the dependencies. We already have added. And it is also saying that we also need to add the SQLite bundle and we already have did this. So let's scroll down and here it is suggesting us that in our common main package we can define all our entities and DAO. And in our local package let's create one more package with the name entity and here let's create one data class with the name path entity. And with this entity we will specify how our database table will look like. And here we will define all the columns we need in our path table where we will save all the paths data. And here first thing we will save the ID of each path, and generally we need to use this integer type, but we will use the long type because later we need this long type, and by default we can keep the null value. And this ID we will not provide ourselves, but it will be generated by the room library whenever we will save a new entry in our table. So here we can simply specify this as the primary key. This primary key we can say auto generate to true. And next thing we will save the drawing tool. So here let's use this drawing tool, and type we will use this drawing tool that enum class we specified. And next we will not save that path right now, but we will save the starting offset. And the type, let's use this float, and let's also change this to starting x offset. This we are saving just to get more understanding on this room library, but later in the video we will save the path to our database. And this data class we need to annotate with the entity annotation. And this entity we can see coming from this room library. With this entity annotation we are specifying that this path entity data class we will use to define the table of that SQLite database. And here in this annotation we have a parameter with the name table name. But for this let's use a constant file separately. Here in our data package, let's create one more package with the name util. It stands for utility. And here let's create one object with the name constant. And we will keep all the constant in this file. First constant we will save the path entity table name. And let's use our constant here. And next thing we need to specify the data access objects. So in our local package, let's create one more package with the name 𝗣𝗏. And here create a new file with the name path 𝗣𝗏. And this will be of type interface. And in this data access object, we define the functions, how we will retrieve the information and save the information into that database. And as the Android Studio is suggesting, let's press tab and import this path entity. So for now let's use these three functions, and again we need to specify that this interface will act as the 𝗣𝗏. And we can see this 𝗣𝗏 annotation is also coming from this room library. And next thing we also need to specify these functions with the annotation. So this function we will use upsert. Upsert is a short of insert and update. So with this annotation we are specifying if the data does not already exist, then it will insert that data into the database, and if it is already exist, then it will update that existing data. And we can rename this function to upsert path. And this function we can annotate with this delete annotation, because this function we will use to delete the path from the database. And next, to get all the paths we don't have any predefined annotation. So here we can write the whole query, and as the Android Studio is suggesting, we will use this code. First let's import this query annotation, and we will select everything from this table. So here we can use the path table. This asterisk stands for everything. So we are selecting everything from path table. And one more thing we also need to keep in mind. Since room needs to ensure that all the database operations happen safely in the background without blocking the main thread, here we need to use the suspend modifier with every function. And if the function is a one-time event like this inserting the path or deleting the path, then we simply use the suspend modifier. But if any function is being used to get a continuous flow of data, then we don't use this suspend modifier. We use the flow return type, and this flow coming from this coroutines flow. We need the flow of path entities list. So this will be our path now. Hey everyone, if you are finding this tutorial helpful, you will love my premium Udemy course where we will build Measuremate, a fitness app using Jetpack Compose. We go in depth on the Firebase authentication, Firestore and more. Check out the course in the description and take your skills to the next level. See you there. Next thing, in our local package, let's create one more class with the name app database. And this class we will use to specify all the things we have related to this room database implementation. And we always need to keep this as the abstract class. And we will annotate this with database annotation from this room library. So the room library will know that this is the database class, and we can select the code from the Android Studio is suggesting, and path entity let's import. Here in this database annotation, first we need to specify all the entities we have. For now we just have the path entity. So here this is how we specify. And the version, since we are implementing the room database first time, that's why we will start our version from the 1. And whenever we change any database schema, then we always need to upgrade this version. And next we have this export schema, and we can simply use this true value. And here let's extend this with room database class from this room library and specify our path now. So our room database will have the path entity and this path DAO. Next thing, let's go to the documentation, and here we can see we already specified the entity and this DAO and also this database class. And next thing, we need to add this app database constructor object. Here we are using this room library in the Kotlin multiplatform project. So this room library will generate some code with this object class. So let's just copy this code, and here in our local package let's create one more file with the name app database constructor and paste our code. Let's import this, and this is asking for the actual declaration. But as the room library is suggesting, the room library will itself generate the actual code for this object. We just need to suppress this annotation. And right now it is giving error, but once we rebuild our project, so this will go away. And we also need to add this constructor here with this constructed by annotation. And here let's scroll down. All this code we have specified. And next thing, here it is suggesting we need to create object of this database individually to each platform. For Android this is the code, and for iOS, but we are not using this, and for desktop this is the code. So let's go to our Android Studio, and in our Android main package, let's open our Whiteboard package and create one package with the name data.local. All these packages we always need to keep similar to the one we are creating in our common main package, and in this way we can structure our code efficiently. And in our local package, let's create one file with the name get room database, and this is in the Android directory, so we will use the android.kt, and here define a function with the same name get room database, and on the Android we need the context to this function, and this function will return us the object of this app database class. This app data class is the same we have specified for our room database. And how the object will be created? Let's go to the documentation and scroll up, and here is the code. So let's copy all this and paste it here. First thing, let's import this room class, and this context we can get from this function. And first thing, we need to specify the name of our database. So this thing we will do in our constant file. Let's create one more constant with the name app database name. So this will be the name of our database whiteboard.db. Let's use this constant and specify it here. And first we have this database builder on this room class. So here this needs the context, and file we already have specified. And next we also need to define few more things. Go to the documentation and scroll down, and we can see here we need to define the driver and this query coroutine context. Let's copy it and paste. This we can get from the library we added in this video's starting, and we are going to use dispatchers.io context, and in the last we will use this build. So this will create the object of this app database class. And in the same way, let's create the object to our desktop platform. So here open our desktop main package, and in our whiteboard package let's again define the same package structure with this data.local, and again we need to define the same file name get room database, but this file is specific to this desktop, so we need to add this desktop.kt. First let's copy some code from here. The name will be the same, but this function won't need the context because there is no concept of context in the desktop application. And go to our documentation. So here is how we need to specify. Let's copy this code, and this is how we specify the file where this database will be saved, and the name we can use from our constant file, this one, and import this room class and make this database builder on the next line. And here we simply need to define the name, not that context. And after that we need to add those three functions. We can make copy from that Android function, these three. So this is how the object will be created on the desktop platform. This is all the code related to the room library. Now let's rebuild our project. So here our project has been rebuilt, and we can see our database constructor class is not giving error anymore. So first let's close all these files and also these two packages. And that's it for this video. As always, if you have any question or suggestions, feel free to drop them in the comments below. And don't forget to hit that like button and subscribe if you have not already. And I will see you in the next video.